Hello and welcome back to Mr. Taufik's Maths and Econs channel. I am so excited to be here today and I hope you are. In today's video, we will be going through the standard form mastery topic, and this is a topic that is essential for the Lagos State BECE Maths, and we will be solving questions, of course, from the past papers. And after the questions that we solve together, you will also have your set of questions to practice and that you submit in the comment section by just typing your answers. Without wasting further time, let's get right into solving standard form question. Now, standard form is a topic that students sometimes get confused about, right? Something I've seen over time, but trust me, it's a very simple topic, and I'll just walk you through the key things to know how to do so you can solve these questions with ease and without any stress. So quickly, excuse me. So we'll talk about standard form. So standard form, right? So that just basically means writing a number in a particular form. Which form is it? The form is basically writing a number in the form of a times 10 to the power of n, where this a can be any number from 1 to 9.99999. Let's just say 9.9 for short, okay? But like it could be 9.999, but this is it, right? It doesn't go beyond this range. It doesn't go less than 1. It cannot have a 0 point, and it doesn't go more than 9. It doesn't go more than 9. It doesn't like get to 10 basically. So sometimes you see written in your textbook like, a is more than or equal to 1 and a is less than 10. So what this just means is that it cannot be 10. It can be 9.99999, 9.999, but it can never be up to 10. Okay, so that's the first thing. Then your n is what? Any positive or negative integer. Okay, any positive or negative integer. And that's where this mistake comes in. Students sometimes don't know when I'm supposed to have a negative and when I'm supposed to have a positive power. And I'll show you today. I'll tell you very quickly how to differentiate when your power is going to be negative or positive. And this boils down to basically the two types of numbers we deal with whenever we are dealing with standard form. We have positive numbers, whole numbers, and what? Whole numbers or decimals greater than 1. And then the other one is numbers less than 1. So number less than 1 are basically, they are always decimals, basically. So decimal numbers less than 1. So all numbers or decimals that are greater than 1, right? So all numbers or decimals that are greater than 1. That's the first part. So whenever you're dealing with all numbers or decimal numbers that are greater than 1, your power, the formula is a times 10 to the power n. This n will always be positive. But anytime you are dealing with a number that is less than 1, then this n will always be negative. That's all you need to remember. That's all you need to remember. So let's look at an example. You are told to write 235,000 in standard form, as well as 43.25 in standard form, right? If you look at these two numbers, these two numbers are numbers that are greater than 1. These numbers are greater than 1. So automatically, they are bigger than 1. You should know automatically that your standard form, the power of 10 is going to be positive. So how do you now write in standard form? Very simple. How do you go from this form to the form of a times 10 to the power of n? All you have to do is, you look at this 235,000. Where is the decimal point here? We can't see the decimal point in between any of the numbers. That simply means the decimal point is at the end. So you now have to move the decimal points, okay, to a particular number that is going to give you the range of values of a. We said a has to be a number from 1 to 9.9, right? So we just start moving to the left. So 1, 2, 3, 4. We cannot stop the decimal point here because this is 23.5. Remember, we said a must be a number from 1 to 9.999. So that means we still have to move one more digit there. Okay, so the answer becomes 2.35. The remaining zeros, you don't have to write them. So how many times have we moved this point? 1, 2, 3, 4, 5. So times 10 to the power of 5. Because this number is a number greater than 1, I know my answer is going to definitely be 10 to the power of a positive number. So what number is it? That number is just how many times you move the decimal point before you got to 2.35. Now the next question. Some students in this example are already confused, like what? This is something like a number in the standard form already, but it's not, because these decimal points, if you look at the way where the decimal point is, this is 43 point something, and we said a must always be between 1 and 9.999, right? Or must always be from 1 to 9.999. Nothing outside of that is acceptable. Therefore, it means that this decimal point, and this is a number greater than 1, so we still have to move this decimal point here, so that it becomes 4.325. So 4.325, 4 points is a number between 1 to 9.9999. So therefore, that is valid. Times 10 to the power of, how many times did we move the decimal? We move the decimal how many times? Just 1 time. So yeah, 10 to the power of 1, and that's your answer. On the other side, when you have numbers that are less than 1, usually they are numbers like 0.000122, right? Obviously, 0.01021, for example. So again, what do? Now, this ones, you always see the decimal clearly. And anytime you see a number that is less than 1 like this, you know your power is going to be negative. So you now need to move this decimal point to a point whereby the number would satisfy the condition for A, which means a number that has to be between 1 and 9.9999. So that has to be a number from 1 to 9.99. So that has to be, you're going to move this 1, 2, 3, and we stop here. Why do we have to stop there? Because that's going to be 1.22. If you move it any one step further, it becomes 12.2. And that's not within the range of permissibility. A has to be a number between from 1 to 9.99. So we go 1, 2, 3, and we stop there. 4. So our answer is going to be 1.22 times 10 to the power of, how many times did we move it? 4 times. But this number is a number that is less than 1. So definitely your power will be a negative 4. The same thing. 1, 2. We stop here. We stop here because going any step further might give you 10.21. And 10 is already more than the range of values of A. It has to be from 1 to 9.999. It doesn't exceed that range. So therefore, we stop at 1. So we're going to have 1.021 times 10 to the power of, how many times did we move the decimal? 1, 2. So negative 2. So that's how to distinguish between when my power is going to be negative and when my power is going to be positive. So if that is clear, let's go on and solve all the questions here without wasting time. You will realize that these questions don't even take any time at all. So question number 1, it says express 0.00000452 in standard form. So everybody here already knows what the answer is. So first, this is a what's it called now? Is a number less than 1, so my power will be negative. So let me see how many times I have to move my power. 1, 2, 3, 4, and 5. I have to stop there because that is 4.52 within the range of what? Within the range of 1 to 9.9. So I have 4.52 times 10 to the power of, we moved it 1, 2, 3, 4, 5. 5 times. Negative power or positive power? Of course, negative power, because this is a number less than 1. So easy, easy, easy. The answer is A. The next one, again, something very easy. Express this number in standard form. This is a number greater than 1, so the decimal point is going to be, at the end, because we can't see it, 571. This is a comma, not a decimal point, 600. So our decimal point is going to be at the end there. So we move 1, 2, 3, 4, 5. So 5.716 times 10 to the power of positive 5, because this number is a number that is greater than 1. Option C. Okay, the last question. You can see standard form is very simple once you know the tactics. Okay, so always remember Mr. Taufik's tactics. Remember, numbers greater than 1 will always have a positive power. Numbers less than 1 will always have a negative power. Easy. A local government receives an education grant of what? 45 times 10 to the power of 4 naira. Write this amount in standard form. Wow, beautiful question. I really love this question. So we have 45 times 10 to the power of 4. Some students are going to be confused, like, but wait, I'm already saying times 10 to the power of 4. Isn't this in standard form already? Well, no, it's not. Why? Look closely at this A. This is 45. But we were told that A must be a number from 1 to 9.9. So 45 is already more than. So we have to deal with that. So what do? You just basically rewrite this 45 itself in standard form. So this is 45. Okay, the decimal point is at the end here. You move it once, it becomes 4.5 times, because I moved the decimal once, times 10 to the power of 1, positive 1, because it's a number greater than 1. Then don't forget there was 10 to the power of 4 initially. Okay, so final answer 4.5 times 10. These two, this is knowledge of indices. This is base 10. This is base 10. This is a power of 1, and this is a power of 4. You can just add the powers. So 10 to the power of 5. And another way to think about it is 10 to the power of 1 is 10. 10 to the power of 4 means 10 times 10 times 10 times 10 in 4 places. Right? This is 10 to the power of 4. So how many 10s do you have altogether? If you count everything, it becomes 5. So 10 to the power of 5. So that's it. And our answer is option B. Okay, beautiful. Now let's go straight into the theory questions. So the theory question is about adding and subtracting standard form. Some of you might have seen this before, but some of you might be completely surprised. Like, wait, what is this? Don't be surprised. It's very simple. There are many strategies to do this. Sometimes you'll be told to multiply this by that to get whole numbers, but I find that to be a little bit stressful. Rather, what I would do, just as you already know, is that I will look at these two numbers. Okay, I can factorize something. Both of them, they have 10 to the power of something to be common to both of them, right? I'll now look at the highest common power. The highest common power is basically 4. So I'm going to factorize out 10 to the power of 4. Okay, open a bracket. 6.4. If you factorize out 10 to the power of 4 from 10 to the power of 5, you're going to be left with 10 to the power of just 1. Take away, which is the minus over here. And this one, if you factorize out, this is minus 2.1. I'm going to write my 2.1. If you factorize 10 to the power of 4 out from 10 to the power of 4, you're only left with just 1. Because 10 to the power of 4 divided by 10 to the power of 4 is just 1. Okay? Just as we know, 10 to the power of 5 divided by 10 to the power of 4. If you cancel, you're going to be left with 1 power of 10. That's why we have this one to be 10 to to the power of 1 over here, right? So this is just going to be 1. So 2.1 times 1 is the same thing. So then we move on to 10 to the power 4 into bracket. Now it makes perfect sense. 6.4 times 10 is just 64. When you're multiplying by 10, as I explained in one of the previous videos, you move the decimal to the right. So it becomes 64.0, which is 64. Take away 2.1. So we have 10 to the power of 4 into bracket. 64, take away 2.1. 64 is the same thing as 64.0. Take away 2.1. You have to make sure the decimals are aligned on top of each other. So 2.1, right? So 0 minus 1 is not possible. Borrow 1 from here. This becomes 3. We have 10. 10 minus 1, that's going to be 9. And then 3 minus 2, that's going to be 1. And then we've got 6 there. So this is going to be 61.9. Hey, then, I mean, this is just the same thing as 10 to the power of 4 times 61.9. Or we can say 61.9 times 10 to the power of 4. Well, some people will think, yay, we got the answer. But nope, you haven't. Because this 61.9 is not yet in the standard form. So that was the trick they're trying to play with you in this question. So since we know that, let's quickly do that. So 61.9 can be written in standard form by itself as what? 6.19, because you move this only once. Because 61.9 is a number greater than 1. So you got to move to the left so that you're going to have 6.19 and then times 10 to the power of, we only move the decimal point once, times 10 to the power of 1. And then times, don't forget this initial 10 to the power of 4 that we had earlier. So times 10 to the power of 4. So final answer, 6.19 times 10 to the power of 1 times 10 to the power of 4 means we're going to have how many tens altogether? 5 tens altogether multiplying, so 10 to the power of 5. That is the final answer. Okay, so that's the first theory question. That is about adding or subtracting standard form. The final question is about multiplying standard form or dividing standard form. And this is the easiest one. Easy, easy, easy. Very, very easy. So the question says simplify 2 times 10 to the power of 3 and then times 3 times 10 to the power of 4 and express the result in standard form. So nothing to worry about, is very, very easy. So what do you do? What do I do? What do we do? What do you do? So what we have to do is do 2 times 10 to the power of 3 and multiply that again by what you have here, which is 3 times 10 to the power of 4. Very, very simple. Let's 10 to the power of 3 and 10 to the power of 4 come together, and these come together. So we can write that as 2 times 3 and then times 10 to the power of 3 and then times 10 to the power of 4. 2 times 3, that is just 6 times 10 to the power of 3 and 10 to the power of 4 means how many tens are multiplying all together? 7 tens. 10 to the power of 3 is 10 times 10 times 10 times 10 to the power of 4, which is 10 times 10 times 10 times 10. Now count all the tens. 1, 2, 3, 4, 5, 6, 7. But a quick way to think about this is just, I have 10 here, I have 10 here. Just add up the powers. 3 plus 4, 7. So final answer is going to be 10 to the power of 7. Ta-da! We are done. And that's it for standard form. Super, super excited to do this with you guys today. And I hope you've learned quite a lot. As usual, Mr. Taufik loves to make sure you're putting your knowledge to test as quickly as possible. So these are your questions. Your turn to, showcase that, yes, I have learned something and I know how to do it. And don't forget, the first 5 people to submit, the first 5 students, the first 5 fastest fingers to submit will be particularly, personally, exceptionally, specially marked by Mr. Taufik, by myself. And the rest of you submit, because this helps you check to see whether you did well or not. Now all you have to do is just go back and see the first 5 that I have marked and use that as a benchmark to mark yourself. This is basically to prepare you for excellence in your BECE exams. I wish you all the very best. So this is the multiple choice question 1, 2, and I move a little bit up to 3, and then the last theory question 4 and 5. I wish you the very best. Keep practicing, keep solving. I'll see you in the next video. Bye bye.